The way a community experiences the impacts of climate-related hazards, including flooding, heat, and precipitation, is closely tied to land use and development patterns. Planning and zoning boards may want to consider which locations and residents are most vulnerable to climate change in their communities and aim to make development in those areas more resilient. To do this, planning and zoning board members need data, and that's where data-driven tools like NJ Adapt can help. NJ Adapt is an initiative of the New Jersey Climate Change Resource Center at Rutgers University that offers guidance and tools to help users understand and address climate-related hazards. NJ Adapt data and tools are designed to support local decision-making, planning and zoning board decisions specifically. NJ Adapt can help users understand climate change risks for consideration in the development of a municipal master plan, and it's especially useful in the development of a climate change-related hazard vulnerability assessment, which is now a requirement of New Jersey's municipal land use law. NJ Adapt can also help with decisions on zoning and land use applications for development or waivers. To find NJ Adapt, go to the New Jersey Climate Change Resource Center website, hover over project areas, and click on NJ Adapt. Here you will find a suite of tools, each with its own purpose. This video focuses on a tool called the Local Planning Navigator, which has the most direct and immediate use in the decisions planning and zoning boards are likely to face. To find the Local Planning Navigator, go to the NJ Adapt homepage, scroll down, and click on the icon. The Local Planning Navigator provides curated data about climate-related hazards, and it's specifically designed to help municipalities address a 2021 amendment to the New Jersey Municipal Land Use Law, which requires the addition of a climate change-related hazard vulnerability assessment to the land use element of a municipal master plan. To address this new requirement, the Local Planning Navigator provides data to analyze the hazards of coastal flooding, inland flooding, extreme precipitation, and extreme heat, as well as to assess impacts on demographics, critical facilities and infrastructure, and community assets. Let's take a look at each of these sections, starting with coastal flooding.
New Jersey's coastal zone covers a vast portion of the state, including 239 municipalities. This makes New Jersey particularly susceptible to the adverse impacts of climate change from coastal flooding. NJ Adapt provides data on sea level rise, hurricanes, and tidal floods to analyze each of these potential flood risks, both individually and through a total water levels approach for various scenarios. The total water level dataset offers a composite of the multiple flood hazards of sea level rise, storm surge, and high tide flooding, allowing users to assess a variety of conditions that might cause flooding to reach a certain water level. Starting once again at NJ Adapt homepage, scroll down to the Local Planning Navigator and click on the icon. Scroll down again and click on Coastal Flooding. In the first section, you'll find a brief explanation of tidal flooding and sea level rise and how they exacerbate flooding caused by storms. You'll also find a brief overview of NJDEP guidance on planning for sea level rise. Farther down the page are links to a series of maps. If you would like to focus on a specific county or municipality, you can make a selection from the drop-down box at the top of the page. The first link takes you to a map showing 2 feet of coastal flooding, which certain parts of New Jersey are already experiencing. The second link leads to a map showing 5 feet of coastal flooding, which is where the NJDEP advises the shoreline may be in year 2100. The third link goes to a map showing 7 feet of coastal flooding, the amount of flooding some parts of New Jersey are expected to experience at highest high tide in the year 2100. All the maps can be customized with a wide range of data sets, including total water level, sea level rise, FEMA flood zones, storm surge heights during hurricanes of various strengths, and much more. Returning to the coastal flooding page and scrolling farther down, you will also find access to data that supports the analysis of potential flood risk for each tax parcel in New Jersey. The dataset was developed by intersecting Mod 4 tax parcel information with FEMA flood zones and NJADAPT water level data. For users with access to GIS, NJADAPT includes step-by-step guidance on creating a Mod 4 property tax parcel data analysis for flooding, which is located under the GIS assessment steps. The analysis allows the users to produce maps and tabular data like this that summarizes the value of property and number of structures at risk from flooding.
Inland flooding occurs along rivers and streams when rain events cause them to overtop their banks. The local planning navigator provides local data sets to help analyze a community's inland flood risks. Once again, from the NJADAPT homepage, scroll down and click on the local planning navigator, then scroll down again and click on inland flooding. The Federal Emergency Management Agency models inland flood hazard for much of New Jersey. The 1% annual flood or 100-year flood shown here in blue is the flood that has a 1% chance of being equaled or exceeded each year. The 0.2% annual flood or 500-year flood, shown here in orange, is the flood that has a 0.2% chance of being equaled or exceeded each year. Users can click on each flood zone for additional information, including the base flood elevation. In 2023, the New Jersey Department of Environmental Protection adopted a new inland flood rule, which establishes a new elevation standard for specific types of new construction and redevelopment. The new design flood elevation is 3 feet above the base flood elevation. NJADAPT has developed a map to estimate the extent of this area to support local planning. In addition to these maps to support assessment of inland flood risks, the local planning navigator includes climate snapshot reports detailing flood impacts from both 1% chance and 0.2% flood events, including effects to power plants, evacuation shelters, farmland, evacuation routes, and the most vulnerable members of the community. The impacts of extreme precipitation have become more apparent in recent storms across New Jersey. Extreme precipitation refers to events where the amount of rainfall or snow substantially exceeds what is considered a normal amount for a location. The annual State of the Climate report by the New Jersey Climate Change Resource Center at Rutgers University indicates that the frequency of extreme precipitation and the duration of summer dry spells are expected to increase due to climate change. The New Jersey Department of Environmental Protection's 2020 Scientific Report on Climate Change also reports that the intensity and frequency of precipitation events is expected to increase, with annual precipitation potentially increasing 4% to 11% by 2050, resulting in anticipated increases in the size and frequency of floods. The local planning navigator provides precipitation data at the municipal level. Click on the extreme precipitation icon. Then on the next page, select a county and municipality from the drop-down menu in the upper right. For this example, we have selected Bridgeton in Cumberland County. The table shows current and projected rainfall amounts locally for different storm events. This is the amount of rain in inches that is projected to fall over a 24-hour period during an extreme storm event. The table includes projections for 2 different time horizons, mid-century and late century, and 2 different greenhouse gas scenarios, moderate and high. In this table for Bridgeton, for example, we can look at the 50% chance storm, meaning that this level of rainfall has a 50% chance of occurring each year. The current baseline is 3.26 inches of rain over 24 hours. Under a moderate emissions scenario, we can expect this to increase to 3.48 inches or about a 1/4 inch increase as we approach the year 2050. Under a high emissions scenario, we can expect an increase of about a 1/2 inch as we approach the year 2100. While these are only estimates, they are important for planning purposes. Heavy rainfall can cause flooding and flash flooding is especially deadly. After an extreme rainfall event, waterborne disease outbreaks are more likely. Water damage and mold in homes after an extreme rainfall event can worsen indoor air quality, exacerbating asthma and other respiratory illnesses.
New Jersey is warming faster than the rest of the Northeast region and the world due to high population density and greater presence of impervious surfaces. This trend is expected to accelerate with further climate change, presenting heat stress challenges to vulnerable residents, including children, the elderly, and outdoor workers. To explore extreme heat in New Jersey, start once again by opening the local planning navigator. Scroll down and click on the extreme heat icon. On this page, scroll down again to the Maps section and click on View Data on Land Surface Temperatures. Click here to go to a larger interactive map. Land surface temperature is a measure of how hot the ground is to touch. Land surface temperature differs from air temperature because the land heats and cools more quickly than air. Data on land surface temperatures can be viewed here based on satellite observations recorded by the U.S. Geological Survey. The deeper red areas coincide with areas that have greater impervious cover, such as asphalt and concrete, that absorb heat. Another analysis available within this tool enables users to explore the concentration of impervious surfaces versus tree canopy and how those surfaces affect a community experiencing the heat island effect. Heat islands are urban areas that experience higher temperatures than suburban or rural areas due to the density of buildings, roads, and other infrastructure. Go back to the extreme heat page and click on this link. Click here to go to a larger interactive map. This analysis is conducted at the census block group level and includes an overlay of areas that have been designated as overburdened communities. The state of New Jersey defines overburdened communities as block groups with at least one of the following three criteria: at least 35% low-income households, at least 40% of residents identifying as minority or as members of a state-recognized tribal community, or at least 40% of households having limited English proficiency. Overburdened communities are indicated with a crosshatch. To explore the regions within New Jersey that may be most at risk from extreme heat, click on the third highlighted link on the page, which takes us to the Heat Vulnerability Index, or HVI. A detailed methodology and link to the interactive HVI map is available on this page. Click on the interactive map. The New Jersey Heat Vulnerability Index map shows the geographic distribution of exposure, sensitivity, and adaptive capacity group scores by census tract. By zooming in and clicking on any tract on the map, a pop-up will explain the overall grouped indicator scores as well as list the individual scores of each variable. This analysis helps identify the communities that are currently most at risk from extreme heat and bear special consideration in planning for future climate change.
Everyone who lives in New Jersey is vulnerable to impacts from climate change, but some people are more vulnerable than others. Vulnerable populations include people with low income, certain communities of color, immigrant groups, including those with limited English proficiency, indigenous people, children and pregnant women, older adults, vulnerable occupational groups, people with disabilities, and people with pre-existing or chronic medical conditions. Assessing the disproportionate impacts faced by these populations is a critically important part of assessing the impacts of climate change on a community. To begin exploring climate change-related impacts on vulnerable populations, go to the Local Planning Navigator, scroll down to the bottom of the page, and click on the Demographics icon. As with all tools in the Local Planning Navigator, you can view customized outputs by selecting a county and municipality in the upper right. You can also view data for the state as a whole. Scroll down again and you'll find 3 options. The first option shows socio-demographic factors at greater risk of negative health outcomes from climate change. Here you will find an overview of demographic data on age, disability, economic status, education, race, housing, and much more within your location of interest. Returning to the demographics page, the second option looks specifically at the exposure of vulnerable populations to inland and coastal flooding. These tables, for example, focus on age and disability. The table at top summarizes the number of people exposed at flood heights of 2, 5, and 7 feet, described as total water levels, or TWLs. The table at bottom represents the number of people in each group living within FEMA flood zones. The data in these tables can also be viewed on an interactive map by following these links. Scroll farther down for charts and maps on minority status, language, housing, transportation, and much more. Finally, the third option in the demographics section focuses in greater detail on disability, with data categorized by age, income, race, language, disability type, and more. Rising temperatures, flooding, and extreme weather pose a hazard to the facilities and services we depend upon for nearly every aspect of daily life. NJADAP provides local data on a wide range of these critical resources. To explore climate change-related impacts on critical facilities, infrastructure, and other community assets, select the Local Planning Navigator. Scroll down to the bottom of the page and click on the Critical Facilities and Infrastructure icon. Scroll down again and you'll find 3 options. The first option provides data on flooding hazards to lifeline sectors, which FEMA defines as the most fundamental services in a community that enable all other aspects of society to function. These include services related to healthcare, law enforcement, food, water, shelter, energy, communications, transportation, and others. These datasets are presented as both Excel spreadsheets and maps. As an example, let's select the Health Map. This map shows the location of hospitals, EMS stations, urgent care facilities, pharmacies, nursing homes, dialysis centers, and other health-related facilities. To the left, under flood hazards, are a selection of map overlays showing, for example, the location of FEMA flood zones or the potential extent of storm surge flooding for hurricanes of varying strengths. There are similar maps for every lifeline sector. Returning to the Critical Facilities and Infrastructure page, the second option provides summarized data about potential flood impacts on built infrastructure such as wastewater facilities, power plants, bridges, and gas stations in your location of interest. Links on this page lead to maps showing the location of these facilities, as well as rail lines and hurricane evacuation routes. Again, numerous map overlays indicate the presence of various flood hazards. The last option in this section is Critical Assets, which provides summarized data on potential flooding impacts to schools, childcare facilities, evacuation shelters, fire stations, police stations, hospitals, and nursing homes. Again, links on this page open maps showing the location of each facility in relation to potential flood hazards. The final area we'll look at is impacts to community assets. For our purposes, community assets are valuable resources within a community that have local significance but aren't necessarily defined as critical. They may be places that represent community identity or otherwise contribute to quality of life, such as historic sites, parks, recreational facilities, and libraries. As an example, NJ Adapt provides a map of historic sites and districts created with data from the NJDEP Historic Preservation Office. In this map, for instance, you can see there are numerous historic sites within FEMA flood zones. Community members know best what is important in their own communities. To help support local identification of community assets, this section also includes a list of potential information sources on community assets that can be added to maps as a custom layer. NJ Adapt contains a tremendous amount of information, and we know that this is a lot to digest in one short video. The New Jersey Climate Change Resource Center at Rutgers University is here to help you with the tools and data. Reach out to us for technical support and to schedule additional trainings.